Thank you all for coming tonight, and so thank you for. I want you to thank all the organizers for putting this up, and New Circle for hosting the event in a very cool place, I think. And tonight I will talk about our robot, NAO, that you may have heard about, like on videos and things like that. It's getting pretty famous. So let's start. First, everything started in the city of Paris in around 2005. So in case you haven't guessed yet, we are French, if you cannot tell from my accent. So we came all the way from Paris to San Francisco for this event and a few other ones. And so it started like almost all stories with an idea. So the guy you see on the screens is our CEO, Bruno Maisonnier, and he had this crazy idea to build robots. But not robots like, with wheels or robots or factories or whatever. He wanted to make humanoid robots. And at that time, it was a very cool idea and very new because if you think about it, like 2005, it was around the first iPhones, for instance. So when everybody was focusing on smartphones, this guy wanted to make robots. And again, we didn't choose like the easy way to make a robot with wheel and all that. We wanted to make like a real robot that can walk, which is actually very difficult, and with arms and anyway, humanoid robot. So we had a few iterations. Started with the early prototypes that you might see, AL01. But again, from the beginning, you can see that this first prototype has legs. So it was planned from the very beginning. And we went through several iterations until we got a design that hasn't changed much since AL5. So it's been 2006. It's been 7 years, almost 8, and the robot hasn't changed much actually. So this is a very cool design, and it was chosen in such a way that the robot actually looks kind of cute, nice, and it's kind of universal. Like if you show this robot in any country in the world, people will be like, "Oh, it's so cute," especially girls, and the children like it. Oh, come on, it's true, right? We have pictures to prove that. And we came up with like almost the final design in 2008. So I told you we're French. So one of the first use cases we had was to make him play soccer. So actually it's a kind of worldwide project called the RoboCup. And the goal is to make robots playing against humans around the year 2050. So we want robots to play against humans and actually win the game. So we're a little far from that now, but that's kind of crazy goal the organizers wanted to achieve. And you have many people all around the world buying our robots and playing against each other every year in different countries, like really the World Cup. So there are other leagues, but we are the robot for the standard league. And a little interesting story, I will talk about this later, but we have 2 cameras, one here and one in the mouth. And the one in the mouth was added, so that the robot can actually see the ground while looking around. Because the first game were like the robot, was looking around him and moving and then looking like this. And that was kind of boring. So that's a fun fact. And as time went by, we had a few other cases that we didn't really expect. So what you see is a picture with autistic children. Like, it was very random, but we realized that children, especially autistic children, had a very good connection with robots because that their main issue is to interact with humans. But it's actually pretty easy for them to work with a robot, and because first this is not a human, so they understand that it's something different. But also we can make the robot like repeat the same thing like 100 times and not getting bored and things like that, which is very difficult for humans sometimes. I'm sure like if you have a cat or a dog, you know how it's like. So this is one of our use cases right now. And apart from NAO, because it's his name, I haven't said it, we also have a European project called Homeo. And the goal is to have a robot which is high like this and like much more powerful, like with kind of big muscles to carry on heavy tasks and very like taller, which is actually also a problem for us because when you design that kind of thing, it cannot be really dangerous. But when you start building robots that are that are bigger and more powerful, we don't want them like to hurt you, and that would be catastrophic for us. And that's something we are working on, which is very, very new for us. And this project is actually very nice because it's a European project with lots of European companies, laboratories, and all that. The goal is to get something like this. So our dream is to have robots in your house helping you, doing stuff you don't want to do, like washing dishes. I'm sure nobody ever likes washing dishes. I mean, I don't. But that's our goal. And we're getting, each day a little closer. So if we look at this, so in my company, we're not really satisfied because it's still, small and we have lots of problems and all that. But when we look backwards, like when we were 5 years ago, it's very impressive because so many things have changed. And we also get a clearer idea of where we are going, and we have new questions. And now we don't care so much, well, we still do, but we don't care so much about hardware and software, but we also have some marketing, philosophical, and all kinds of questions that were not like our main concern like 5 years ago. So this is kind of cool. There are even people who want to take this robot to Mars. So that was kind of unexpected. I don't know if they're going to do it or not. But I can understand because I wouldn't go to Mars with a Roomba, for instance. It would get pretty boring, although there is a lot of dust. But that's cool. Yoo-hoo. And this is us today. So we started in Paris. When I joined the company, we were like 30 people. Now we're more like 350 employees worldwide. So we have offices in Boston. I know we have nothing in California. It's a shame, but we're working on it. And we also have offices in Shanghai and Tokyo, which is not really surprising, I think. So I told you we had many projects, and we mainly sell robots to geeks. Well, we have what is called the developer program. Yeah, good. We also sell robots to universities. They really work with a robot, like they have some kind of workshops with students and all that. We have researchers who are doing all kinds of stuff with the robot. So this kind of robot, because again, it's human, so they were working on interaction, emotions, and so dynamics, things like that. So this is our main business right now. So we have more than 6,000 users worldwide. I think we have sold like 5,000 robots since the beginning, something like this. Of course, some of them are broken right now, but still. Oh yeah, and that's actually the last figure. It's more than 4,000. And I will talk a little about this guy. So this picture was taken in the South Pole because a researcher was going for a very long mission, like I think it was a year. So he took his robot with him, and he actually wanted to take a picture with the penguins. So that's kind of fun. So instead of talking, I will let him do the talk.
What do you want me to do?
Presentation.
Presentation. Let's talk about me.
The table is like not very stable.
Hello, my name is NAO. I'm a humanoid robot imagined and manufactured by Aldebaran Robotics. I come with a software and I'm fully programmable. I'm autonomous and I can connect to the internet through Wi-Fi. I can recognize your face, answer your questions, play music, grab objects, and even play soccer like a pro.
That's good. Like a pro.
I've more than 5,000 brothers and sisters and use all around the world in universities and research laboratory. Do you want more technical details?
Yes.
counting every articulation in my body, I have 25 degrees of freedom. The sun is located on my torso, allow me to detect obstacles that I might encounter. My 2 cameras give me an enlarged field of vision. Thanks to them, I can look right in front of me or at my feet, to avoid walking where I should not.
Or playing soccer.
The 4 microphones around my head allow me to detect the origin of sounds nearby. Oh, well, I think about it. There are 4 force-sensitive resistors under each of my feet combined with my inertial sensor. They help me keep my balance. I can use some legs to express various emotions and interact with you.
Oh, by the way, you can take pictures.
On the other hand, can use my tactile sensors on the head, for example, to pass me some information. Well, I guess that's enough for the moment. Thank you for listening to me.
Thank you.
Do you want something?
Sit.
Sit down.
Yeah. So, when you have robots playing football, I mean soccer, sorry, I'm European, you really want them, to be able to get up when they fall, because they often fall during the games, and that's an important use case. So I said we're working on humanoid robots, so that's important, but we don't want to make humans. This is not our goal. We want to make robots that are kind of like humans, but are real robots. And that's important because they are able to do all kinds of stuff we cannot. So like you're not really equipped with ultrasounds, for instance. And you don't have that memory, that a CPU that powerful and things like that. So we are more, like thinking about it as a new species, for instance, that, trying to make the same things as humans, like in a very global way. So we are really, how would I put it? We want to make robots. We don't want to make humans. So anyway, this is basically what he said, but I'm going to review all this with a little more comments. So we have 25 degrees of freedom. So we have motors in the neck, shoulders, elbow, wrist, hips, knees, ankles. We have, so you can control the motors, complex movement. Again, it's capable of playing soccer and, to keep its balance and doing things like this. Interaction, because that's a very important thing for us. We want the robot to be able to interact with humans. So we have 2 loudspeakers, and I know it's not really logical, but they are in the ears. And that's the problem, actually. And we have microphones that are here, here, and on the side. So, when people want to talk to the robots, they always talk to the ears, which is actually not always a good idea, because when there is some sound coming out, when the robot is not understanding anything. So it's, let's say, a design issue. And that's one of the things we didn't really think about at first. So we have LEDs pretty much everywhere. So on the skull cap, in the ears, the eyes, torso. We also have some LEDs here on the feet. You cannot see them, but it's mainly to know the temperature of the motors and things like that, to get some feedback. Tactile sensor on the head. So it's a capacitive sensor that can be used to interact with the robot. But this is like more a workaround, because ideally we would like to interact with the robot the way I interact with you. Like I talk and I'm not touching your head when I want you to do something. Not sure that would work. So same with the buttons and all that. So we have hands, like very basic hands, that are just able to do, like to grasp something. We were thinking about getting hands with more fingers, but that was like the first try, and it's kind of successful. Infrared sensors, so you can actually use a remote with the robot. But again, it's some kind of technology from the past, so we are thinking about removing them. So they are here, by the way, in the eyes. We have Wi-Fi connection, of course, and Ethernet too, so it's located. I'm going to put this down. On the back of the head. Oh, it's hidden. So we have a USB port, and you can plug an Ethernet cable. Ah, stop moving. Sorry?
It's a host port.
Yes. Stop moving. Because he's reacting to sound right now because, as he said, he has 4 microphones. So he's trying to look where the sound comes from. So when I talk and I'm trying to do something with his head, it's kind of painful. Sense, yeah, as I said, 2 HD cameras for microphones. So the FSRs, for those who don't know, are sensors under the feet. So that robot knows when he's standing or when his feet are not touching the ground. We have an inertial sensor, which is really cool. I will try to make it work a little later because I don't want to screw everything up right now. We have bumpers here. So it was mainly designed so that the robot, when the robot hits a wall, for instance, he knows about it. And so when he plays soccer and is shooting in the ball, it also knows about it, gets some feedback. And sonars are here, ultrasound. So you can detect obstacles. Like if the robot is going close to a wall, it knows about it, the way like bats do. And think, between quotes, we have an Atom CPU, which is getting kind of old, so we're working on a new version. We have 1 gig of RAM, which is also getting crowded a little. And we have flash memory, and well, the software suite is what you use to program this robot. Because as the robot said itself, it's fully programmable. So you can basically use all the sensors I talked about. You can control the motors. You can do pretty much everything you want. That's physically possible. Yeah, so I want to try something. And it's a fail. OK, so in this mode, it doesn't detect the falls, but it should have. Stop. That's surprising, though. No, it doesn't. Oh, it does. So it detected the fall, and it's going to get up. But on this table, I'm not so sure. Yeah. No, he wants to sit. No, he wants to get up. Ta-da! Yeah. It's always very fun. So when you are doing a presentation, if the robot falls, it's not really a problem because then the robot tries to get up. And actually, it's a better thing for the audience because like, oh, it can get up and everything. So you can never screw a presentation with this guy, which is relaxing.
How sturdy is it if it falls down the table and will break?
No, so actually, before you arrived, maybe some people were here. The robot fell from the table. That's why I'm being careful. And well, it's still alive, right? It's not broken. But like 5 years ago, when the robot would fall, you would get old PCs everywhere. And, like that, one of my first day at Aldebaran, I made a robot fall, and there were PCs all over the place, and I was so worried. People were like, yeah, it's normal. That was fun. OK, I guess that's pretty much it for. So as I say, we have a bigger version called Homeo, which is 1.58 centimeters high. I don't know anything about your units, so I will let you convert it in inches, yards, or whatever. Although yard is kind of big. And yeah, so our goal now is to get something bigger that can do more interesting things, because it's very small. It doesn't have like a lot of power to carry things and all that. So we take it as a prototype, a cute prototype, a working prototype, but this is not enough, and this is not where we want to go. OK. Oh, and by the way, the battery is behind. So we have between 45 minutes and an hour and a half of autonomy, because we didn't really work on that. That's also something we want to improve. All right, so let's move next. So for the rest of the presentation, I will use this one, which is not in a live mode. So do you still want to take pictures, or are you done? I will do that later at the end.
Safety mode. Pat me on the head to go back to the solitary life.
Yeah, it's live. And I will use this one, which is completely numb. I'll try not to lose the Ethernet connection. So they are from the same generation, so exactly the same. You can tell the generation from the color. Like we started with blue, red, green, orange, and now it's blue. No. All right. And it's not alive. So let's get more technical. This was like a basic overview to make you understand lots of things. But most of you are developers, I guess, and you are interested in how things work. So we have software running in the head. We have two CPUs. We have a ARM processor in the chest, which is mainly used as like, how do you call that in English? The nerval? No. You know what you, system nerve, like nervous system, nerval system? Yeah, nervous system, okay. So it's basically detecting, like, as I said, inertial data and making all the models move and all that. And we have the head, and the head is used mostly for processing data from the sensors. Like, oh, I'm falling, and okay, I see a human, and all that. And the atom processor is in the head. And this is where we run our software. So you cannot access the chest. And our software is like a framework, which is called NAO. So maybe some of you have studied or know Japanese and Chinese. So I think in Chinese it's chi. It's like the soul, something like this. So this is basically the soul of NAO. And our software is organized in modules. So we have many modules. So I have a list here. AL memory, which is like a global memory of the robot, short-term memory. We have motion, which is like the module used to deal with dynamics, make the robot move. We have text-to-speech, so you just feed him some text and make him speak. Speech recognition, so you can talk to the robot and the robot will understand and know the way you use Siri, for instance. Video device, to deal with cameras, battery, face detection. Because through the cameras it can recognize you, or at least you can train him to recognize you. Audio source localization is what you saw moments ago with the other robot. He was looking in the direction of the noise. But since I'm the only one noisy here, he was only looking at me. Navigation. So we're working on making this robot like walk in your apartment and remember where is the kitchen, bathroom, and all that, and avoid obstacles. So audio player to play sound and lots of other features. I just listed the main ones. And what is cool is that you can write and add your own if you are motivated. Well, and if you want to, you don't need to be motivated. But and so each module is like a running object. And this object has an API. So for instance, the memory module has some methods to insert data in the memory, get data, to raise events. So we have like a globalized event system onto which you can subscribe. So to take the motion module, as I said, dynamic of the robot, you have the walk-to API. So if you call walk-to with the parameters, the angle, and distance, and all that, the robot will go to where you said. The LEDs, if you want to control the intensity of the LEDs, make them fade, and all that. And so for each module, I said we have an API that is available in the documentation. And take this software again as a framework upon which you can build applications. So this software is not doing anything. It's just available. And what you've seen, the life of the robot, is just an application built on top of our framework on NAO. So this is a little technical, but just to let you know how it works, we implement modules as dynamic libraries. Our main modules are written in C++ because we need something like, first we want that to be very fast, efficient, and this is our main language at Aldebaran. But the nice thing is you can write modules in any language, almost any language you want. So we have been supported Python from the very beginning, and we even went through the Ruby Python war and Python 1, like everywhere else. But you can also, I will show you Java. I also have some JavaScript bindings. And our framework was designed in such a way that we would like to open source it. So it's not that clean right now, so I can shame, but we're going to do it soon. And people can write their own bindings, for instance. Like you're doing C#, you want to write your bindings and make them available for like your community. But first, we have this idea that some talented people might have very good ideas for robots, but might not be developers. So we almost, from the beginning, we started working on a GUI called Choregraph that can be used to make the robot do things, but very easily. So as you can see on the screen, we have like 3 kind of panes, although you can have a lot more. C is a virtual view of your robot. So if you have no robot, then you see just like a kind of simulator. And if you have the robot, the 3D view here will just be in the position your robot physically is, currently physically is. B is like your workspace, in which you would put the boxes that are in the A pane. So we have standard boxes that are designed and doing like atomic actions, like talk, get up. I want to catch this sensor, for instance. And this GUI, again, was designed to allow people who are not really developers, who are not geeks, to play with the robot. So this morning we were with Stefan Chin, that you probably know, and we went to a school and we were with children. And those children, after maybe, I don't know, 10, 15 minutes, were actually able to design behaviors and play them on the robot and make him do things. That's really awesome. It's very powerful. And how it works is it's like basically a flow diagram. When one box is over, it has some outputs, and it triggers the next box. So I'm going to show you a little how it works. So this is the view of my robot. So as I said, the 3D view is in the position of the robot. And you can see the camera that is actually looking at you right now. You can smile. And we're going to play a little with the boxes on the left. I don't need that. So we want to say something. So we just drop the say box. And this is the beginning of the behavior. And this is the end. Oops.
Hello.
That's very nice. Like, it took me 3 seconds to build something that actually make the robot talk. Yeah, this is the kind of hello world. So it's very nice because for people who don't know anything about computer sciences, they can actually play with the robot and design things. So we find it pretty cool, and it's usually very rewarding because we see that the users quickly understand how it works and build nice stuff. Like we were in Poland 3 weeks ago, right? 1 month ago. And we had people, working on the soap opera with 2 robots, like who were married and arguing and all that. And so they had never played with a robot before, but they were able to create something like a small movie and play it in front of everybody. That was kind of fun. So how it works? So you can see the wires, and it's a sequence. So what could I use? LEDs maybe, I don't know. Let's say blink. Oops. So you can tell from the way this thing look that after saying something, the LEDs will blink, hopefully.
Hello.
You've seen? So it's very sequential. But you can do like more powerful stuff, like react on events. So if I use the sensing boxes, like tactile head, so you can see that you have several output boxes. So the first one is when the box is over, but we don't care in that case. The first interesting one is the front touched. So you cannot really see it, but we have actually 3 different areas for touching. So we have front, middle, and back. So I can design a small application that will be triggered when we hit the front tactile sensor. So this is what I'm doing. We put everything all together.
Hello.
So in 3 boxes, I have something that reacts to exterior events. What else can I show you? That would be very cool. So we can also make him speak his name, for instance. So I'm going to use the output of one box and feed it to another one. So we don't need that anymore. So let's still keep that.
Now.
So his name is Now. Because you can also give him like a pet name, which is different from the factory name, you know, to recognize him on the network when you have several robots and all that. And in that case, so it's a type output. So you can see that the type of the output is string, and luckily the sayText box also takes a string. And we handle many types of data like ints, strings, like bare events, like no value and all that. And we also, so sometimes you want to patch a box or to create your own boxes. And this interface actually completely supports Python. So you can write your own boxes in Python. Right now, we are only supporting Python, but we would like in the near future to have other languages available. So I would say Java, of course, but we want it to be more generic than what it currently is. But we never had a need for that because, you know, we felt like Python was enough at that time. But anyway, you can write your own boxes.
Can I ask a question?
Yeah.
How does what actually executes on the now itself?
Everything.
No, what I mean is like, what does the code, like your Python code executes as is on the now, basically in its own process or something like that?
Yeah, so the Python code is sent to the robot, and the robot has a Python interpreter in that case, and it will run it.
Got it.
Or it could be a process, C++ process, or that kind of thing. But it's not executed on my machine, it's on the robot side. And you can, yeah, we can do more interesting stuff like speech recognition, for instance. Speech reco. So I think, yes. Okay, let's try this. So I'm going to make him listen to me and repeat what I say. No. Say text. Robot.
No.
Didn't understand. Let's try again. Robot.
Yes.
So it understood something. And so I know there is a way then to get the understood text, but no, so it understood yes actually instead of robot, which is surprising. Human.
No.
Not very successful. But anyway, we have speech recognition working, when I was trying to launch the presentation and things like that. But of course, since it's a demo, it's not going to work, right? We all know that.
Do you understand French better than English?
Actually, no, but yeah. No, it's very fun to see people in Paris working on the English side and speak English with a French accent and try to get understood by the robot. That's actually something very fun. And now they have this kind of robotic English accent because they know how to get understood by the robot. And speaking of which, we handle like 15 languages. 19. English, French, Spanish, Japanese, Chinese, Polish, lots of different languages. And we have started working with Nuance. I'm sure you know Nuance from they're working for the iPhone and all that, like it's #1 in the world. And we are going to have a new voice specially crafted for us and for the robot. So it should be coming very soon. That's very nice because the English voice right now is not that good, I'm sure you've noticed. So anyway, this is Choregraph. And it can be used not only like to play with the robot, but you can design like real big applications. So I know that for me at least, maybe for you also, it's kind of weird because we like dumping codes and running nice programs in nice files using some weird editor. But it's actually very nice to build a program with this software because you focus on the essential. Like you can, I haven't shown this, but you can make groups of boxes and you just design the input, the output, and you have like a high-level overview of what the robot is going to do. And that's actually surprising because I never really liked GUIs. But it made me understand that sometimes you just want to focus on the architecture. And for that, this tool is very nice. It can also be used to, when you're done, so of course to send the application to the robot and play it, but you can also build a package. And that package is like the, how would I say, the exported format for the application. So you can share it with friends, you can put it on our store. I will talk a little more about this later. So anyway, this was Choregraph. And we have many boxes, like start behavior, it's like starting an application. You can use infrared, motion. What else? So the postures are, you can make him sit, you can make it stand up, and like go to predefined postures. System, memory, trackers. Oh, we also have trackers, so the robot can recognize things. So like by default, a ball or a face. But you can also train him to recognize forms. Like what we had in Poland was a guy, he would make the robot recognize his shoes with the Nike logo. And each time he would show the robot his shoe, the robot would say, "Oh, you have nice shoes." So that was very fun and very easy to do. Yeah, I think that's pretty much it. Or you can also use, like if you can't think differently, you still have like control structures like if, all the loops and all that. Anyway, all the features of the robots are available as boxes in this software. Oh yeah, I forgot to say something. Like you can put things in parallel. Like maybe not this one, but okay, I'm going to try to make him stand up. Which is probably a bad idea, but. So what do you think he's going to do? Okay. So he's going to stand up and talk at the same time.
Hello.
See? Oh, but it stopped because the application stopped, because it reached the end. So now it's stuck in a funny way. I'm going to unstiffen it.
Stiffness removed.
So anyway, you can have a lot of fun with this robot. Okay, that's it. Going back to my slides. So our framework, NAO Key, is built upon a new library that we have entirely written from scratch, which is called key messaging. And it's designed, as I said, to be like completely cross-language. You can write your own bindings on top of this and make any language talk to the robot. But it wasn't designed to be a robot framework. What we do is you can create services on the network and register them to a service directory, and they can then be used by anybody in any language, because as I said, it's cross-language. And it's a way to expose, to bind objects on the network, and objects with an API and all that. It's actually pretty cool, and that's the thing we want to open source. So how does it work? So you will see like snippets of code, but an application is just something we need to create, to start all the event loops and all that. It's not really interesting. And a session is a connection to a robot or to a key messaging network. So you first connect to the service directory, and you say, OK, I want the text-to-speech module. And the service directory will tell you, OK, this is the address. And then you can connect to that module and access all the APIs. It's fully introspectable. And again, cross-platform, because it has to work on, it can work on Mac, Linux, Windows. And that's also the protocol used by the Choregraph software to talk to the robot. It's the protocol used internally in the head of the robot between all the modules and all that. And again, that's something we rewrote ourselves. Think about it as a way to advertise a service on, yes?
What sort of relationship is there between your framework and ROS?
None. But so we share like some common ideas, like you need services on the network and you need to access them. But apart from that, we share nothing. Yeah. But we are not so interested in ROS right now. I mean, we have no point in working with that. But that's a good question. It could be a ROS equivalent, but with different philosophies. And so the way you will work with the robot is you will get, so if you are developing on a very low level layer, you will get proxies to those modules. So for those who don't know, a proxy is like an object that will act as a mirror of something else. And you talk to that object locally, and it will do all the networking to talk to the real module and access the real APIs. So you never know if a module is in the same process as you, or if it's remote, if it's in the robot, if it's outside, if it's in the web. You never know. So I'm going to talk a little bit about Java, because this is what we're here for. It's never really been a priority for us, because so I think Java from the beginning didn't really beneficiate from a strong support in our company, and it had like a very bad reputation for embedded software. I mean, I know some people wouldn't agree with all the Java cars and all that, but when we were thinking about Java, we're like, OK, it's very heavy, and we have, at that time, we had a very bad process, a very bad CPU and all that. So it wasn't our first choice, why we moved to Python. But now we are starting to consider this, because, so first, there are very big communities all around the world. You have like a strong manpower. It was the most successful languages. And of course, Android changed a lot of things. So the typical use case would be to use the key messaging framework on a phone to talk to a robot and develop an application that would be like, I don't know, a remote, for instance. You want to tell the robot, OK, get up, sit down, bring me some beer, something like this. And this is why we need, some people are interested. But you would typically write this in Java, and this is why we need Java bindings. So we started working on it like maybe 6 months ago. So it's not really mature. And it's actually not easy to find like the perfect developer for that kind of work, because our framework is very low level, and we have a hard time finding somebody who would be like, at the same time, a C++ expert and a Java expert. So we did things in our way, although we're not really like Java experts. You will see. But anyway, I will talk about this a little later. But if you are very good in Java and C++, we're hiring. But yeah, but not exactly the same way. But we'll talk about this later if you want. It's like, yeah. So as I said, we're hiring, but we are in Paris. So, but Paris is better than San Francisco, so shouldn't be an issue. So this is a very short example of Hello World. So as I said, you need to create an application, but we don't care about this. And you create the session. So as I said, the session is the connection to the network. And you would connect to the service directory. This is where all the first requests will go. Like, OK, I want this service. So we first connect, and then we have, so everything is asynchronous in our framework. So we have like a kind of future mechanism. I'm sure you know about this. So future, AKA promises, AKA deferred objects, that kind of thing. So basically, you make the call and it returns right away. And then you need to wait, or you can add the callback to get the result later. And this is one of our very bad ideas, which was to name a proxy object. And from time to time, it gives us some very headache. I apologize publicly for my company. So we create a text-to-speak object, and we will call the session.service method to get the proxy to text-to-speech. And then we can call the same method with the right parameters. So I'm not lying. I'm going to close this. Discard. OK. Yep. I'm not spoiling everything. So this is the code I just showed you with a little improvement at the last line. This is the Java code, and we provide the Java framework with a version for the CPU of the robot, which is just an Intel Atom processor, but also for your own machine. Like you can run the Java on your computer, for instance. Because as I said, you can connect to the robot whether you are inside or outside. It never makes a real difference. And so we provide a jar for key messaging, which contains like the application, object, session, future, everything I told you about. And once you have your editor set up and all that, you can just hit play.
Hello, world from Java.
And this is working. Right now, though, we don't ship with a runtime environment for Java in the robot, although we're going to fix it soon. But we are struggling with other problems. As I said, the CPU is getting very old, and we're trying to do too many things. When we have a robot working in a live mode, recognizing faces, processing sound, and all that. So we are waiting for a new version of CPU to allow running Java and other stuff. But you can still do it like you just SSH to the robot, and you start the JVM yourself and all that, and that works. No problem. So it's not really complicated. If you want to build an application, you will get all the proxies you need on all the services, like, again, motion to make him move, the LEDs to make him do crazy things with his eyes and ears and all that. And then you would use those proxies with all the methods that are listed in our documentation. And you can build very nice applications. Like we have people telling stories with that, for instance. Like we have the Three Musketeers, we have Star Wars. Maybe I will show them. Some people are doing very interesting stuff. So I'm going to show you another example. Take picture. So how does it work? So if you look at the main method, so we first get an application, as I said. So the util.get session is just some boilerplate code, sorry, to get a session connected to the robot and all that. Then we create a take picture object, and we call the run method. So as I said, you just get the proxies to all the modules you need. Then you call wake up. Wake up is to make the robot. So right now his idle is not doing anything, but wake up will stiffen all the joints and all that. Rest is so first wake up, say smile. So if you look at the say smile code, you just call the same method on the TTS to make him say something. Oops. And then we'll make him take a picture. So if you just read a little of the code, I'm sure you understand what it does. And that's what I'm going to run right now. Oop. Yes, so some people made the experiment of plugging a Pico projector in the head on USB, and that's really cool. But it's not really efficient because, you know, when you're outside, for instance, where do you project to? So we're also interested in, have you heard about Leia? No, it's a device, you know, they just sprinkle some steam and they're able to send light through it, and you have like a real screen. Yeah, it's not really hologram because it's only 2D, but you have a screen, and that's really cool. But anyway, playing.
I'm going to take a photo. 1, 2, 3, smile. Sending you the picture by mail.
So if it hasn't lost the internet connection, I probably have received something, or I will soon, because we have a 3G router, so I'll let you know if it comes. Well, anyway, you can see the picture, and it was like a very short code using a few things, like stiffening the neck so that robot looks in front of him, and talking a little bit. It's like, so I don't have the number of lines, but maybe like 150 lines. It's very, very simple. And yeah, that's it. I don't have any cool Java stuff to show you because we have something very generic. Like you get proxies, you call methods. Right now what we need is like a real Java layer to make things done in a more Java way. And oh, I forgot this slide. Anyway, yeah, so this is the current status. As I said, the Java philosophy of our bindings can be improved, and that's a euphemism because we were some bunch of geeks saying, oh yeah, Java is cool, so let's try to do something. But I've never really been a Java expert. I've done more like C++. I was a kernel programmer for VMware, so let's say that Java is not like my main domain of expertise. Also, we don't have a very good integration with IDEs. We need to set up a lot of things, like with Eclipse and all. As I said, our application layer doesn't support Java. You cannot write applications in Java right now and launch them right away. You need to hack a little bit in the system, start the JVM and all that, copy the files on your robot and then start them. So we have no runtime on the robot. And also, do we have any, is anybody in this room, does anybody in this room have a robot, NAO robot? No. So just to tell you that our latest public release was 1.14, and Java is available starting from 1.22, which should hopefully become public soon. We are working on the last bug fixes. So anyway, it's not yet available publicly. So to be continued. This is just the first step, and we're working on making like it's more Java friendly for you guys. Because again, if I gave you like a robot right now with the SDK, you would be probably crazy because it's not so clean. So if you're interested in this robot and working with it and all that, we have a community that's building up with a forum and people helping each other. And we have a store, like the Apple Store, Android Store, where you can write your own applications, publish them, and sell them and all that. So they get automatically downloaded by the robot, and then you can ask the robot. So the way I launched the presentation, you can ask the robot to launch any other application. So you can join the community even if you don't have a robot. In that case, you would get the Choregraph GUI with a simulator, and you can start doing stuff with it. It's kind of nice. If you want to try, give it a try. I'll show it to your children. They usually like that stuff. And for more information, you can just visit our website and see where we're at. So thank you very much. This is from our apartment next to the Auckland Bay Bridge.